I love that like the front half just kind of emptied out once I came up here. That was pretty great. All right, so before we start, I'm actually going to ask you a favor. So I want everyone to start out by taking out their phones. Everyone, well, okay, Patrick is not. If you work here, you don't have to, but everyone else, take out your phones. So, all right, phones out, everyone. There you go, you got them out. All right, I want you to open up your email app. All right, you all got that? Compose a new message. All right. And then when you're there, in your from field, put in my email address there. So what I want from this is that you all to save a draft. So any of you that have any opinions on MongoDB, the company's relationship with Rust, do you use Rust at your company and want to use MongoDB? Do you use MongoDB and want to use Rust? Any of those things, just even if it's just a few words about your situations, save a draft, remember to send it to me later. And I'll come back to why that's important in this last part of the presentation. All right, so starting out, who am I? I'm a software engineer at MongoDB. I work on the drivers feed, which is the software used to connect to the database rather than the database itself. I'm currently working on the ODM projects, which includes the driver itself, and also the Mongoid ODM, which works with Rails. One fun thing to learn about the Ruby community, nobody uses the driver like by itself. Everyone uses Mongoid. Sorry? And I'm also a Rust enthusiast, so I co-wrote and co-maintain the unofficial MongoDB and Rust driver. So as Michael so graciously pointed out, it is not currently production ready, and that is because they're paying me to work on Ruby instead of Rust. Not up to me to change that, but yeah. And I also spoke in November at the Rust meetup for any of you who were there. I have a link here, I'm going to post the slides online for tonight, on how to write error-safe code in Rust. And so what we're going to go over is a kind of past, present, future thing. First, we're going to talk about the history of the relationship of MongoDB with Rust. So like, when did we start writing the driver? Is this the first time we decided to write the driver? How did that happen? In the present, we're going to talk about why I think Rust is a good choice for using with MongoDB. And I'm also just going to have a quick slide talking about some various projects I found online of people using MongoDB with Rust. And in the future is kind of a hypothetical, like if MongoDB did an official Rust driver, what would that look like? And so we'll start by going back to the past. All right, so the first time we tried to write a Rust driver was in 2013. It was an intern project. This was before my time at MongoDB. It supported Rust 0.7, which if you use Rust is just ancient. So we used make for building and pandoc for creating documentation. Nobody in Rust uses those things anymore. There's official tools, cargo, and rustdoc. There's a lot of weird syntax when I was looking through that I didn't even recognize because I started Rust later. If you wanted a heap, you use the little tilde for a heap allocated thing. And then there's also this @ symbol that for the life of me when I Googled, I could not figure out what it did because it is impossible to Google for. I don't even know the name of the symbol. But apparently you put it before struct literals in Rust 0.7 and that's not there anymore. But what this demonstrates is that Rust changed really quickly and the code became quickly out of date because that's what happens when things have a version number beginning with 0. So we tried it again 2 years later in 2015. This was another intern project. It was written by myself and Kevin. I don't think I saw him here tonight. He is K down on GitHub if you want to go and look up this stuff. One really just coincidental thing is that we started writing this literally less than 2 weeks after Rust 1.0 came out, which means that we wouldn't have to deal with the code going out of date again, which was just kind of perfect, which is why it still works today. And we published it as the MongoDB crate at the end of the summer, so there was someone else who already had that crate, but they weren't really using it. So we reached out and we were like, hey, any chance you're willing to give this up? And they're like, oh, definitely, which was just very nice of them. And so we have it in a repo that is now called Mongo Rust Driver Prototype because all of the official MongoDB drivers are Mongo-language-driver. So we just tacked on prototype and just put a bunch of giant disclaimers saying like, maybe don't use this in production yet. And since then, we've done a couple of big changes. The biggest one is switching from Rust C serialized to Serday, which we heard Michael talking about that. Serday is really just one of the amazing things about the Rust ecosystem. And so when we switched over to it, I wasn't involved in that. I was kind of like, why is this important? And looking back, that's like one of the most important things we've done about the driver. We also added TLS support, which for the time being is used against OpenSSL, so you have to compile it as a feature so that I can link to it. But making it a feature means that like, if you want to install it and you don't have OpenSSL installed, it still works fine. And a bunch of bug fixes and minor feature additions. So that brings us to the present. And I'm going to start by showing some sample code. I took a while trying to figure out how to fit it on the slide, then I'm like, wait a minute, I'm in a web browser, I can just kind of open a link. So this is tiny, I'm guessing, so let me zoom in a bit. Do that? All right, so imports. This is pretty typical to what you see in most MongoDB drivers. You create a client, in this case we're specifying localhost in the default port. We use the client to get a database handle, and from that we get a collection handle. This is one of the cool things about the Rust driver. We have this awesome macro for making documents that basically look just like JSON. So you don't have to worry about like making a bunch of different documents and inserting them inside each other. You just kind of write syntax, and Rust macro system can let you support that. So we're just inserting a document, getting a cursor out. So cursor implements iterator in Rust, but you can also just get the first thing by calling next. And then finally, you can pattern match on what you get back. So one interesting thing is it returns an option of a result of a document. Why does it do that? Well, for starters, the iterator trait in Rust, and if you're not familiar with traits, they're kind of like interfaces, only like with a lot more features. And so the next method on it is defined to return an option of some generic type. Which makes sense because when you're iterating over something, you keep getting the next thing until you don't, and that's when you're done. But in this case, any call to next might be the call where you get an error. Because MongoDB, if you make a query with like, and you get 10 million results back, you're not going to stick them all in memory. It gives each of them in batches. And part of the benefit of using a driver is it abstracts things. You don't have to say, hey, am I out? Give me the next batch. Give me the next batch. But because of that, any call to next might be one that triggers the next batch, so it might have an error. And in Rust's type system, since errors are strongly typed and you have to handle them, that just means that you check whether the result is an error or whether it's okay, and you get a document. And yeah, this quick side note, that's one of the things I really like about Rust ecosystem. Michael touched on this too. It's very, very hard to not handle your errors properly. You can't just be like, oh, it might throw an exception, but I don't have to check it because the compiler doesn't make it. No, the compiler makes you check your errors, and that's a good thing. Okay, so going back to the presentation, and I don't know, where there we go. All right, and full screen, because my computer's lagging. All right, so next we're going to talk about why should you use Rust if you're using MongoDB. So this is geared more towards people who are using MongoDB, but using some other language and don't know why they would use Rust. So the two main things here are things I touched upon briefly, great BSON library and error handling. So for the BSON library, like I said, the doc macro, I don't think there's any other driver in the MongoDB ecosystem with the exception of the dynamic ones where you just use maps, where you could define a document by just like writing a document. In JavaScript, you'll get that. You won't necessarily know that the type you put here is a type you can put in a document. Same thing with something like Ruby if you use a hash. But in Rust, it will give you a compile time error if any of this is malformed, and it just does all the work under the hood for you at compile time by generating the code that would be done if you manually created the documents. Also Survey, so I just wanted to show a code sample with this. Michael showed that as well. So basically, if you want to be able to just map your structs into BSON documents, you can just define a struct, tell it to derive serialize and deserialize, which means I can go from struct to document and document to struct. You can use a bunch of features like renaming fields, there's a lot of crazy things, and then you just kind of say, make it into a BSON and check if there's an error with that little question mark Michael was talking about. And you can say, if the BSON is a document, then I get this. Otherwise, it's like, hey, convert it to a BSON type that's not a document, which may or may not be valid depending on your use case. All right, speeding right along. Error handling. So here's an example function of how you like to do error handling with the Rust driver. So the idea here is, let's say I have some documents in my collection, some of which have an X field that's an integer, and some of which might not. And I want to add in all of those integers in a really ergonomic way, but also make sure I handle any errors. Well, in Rust, you do that by writing a function that takes in a pointer to a collection. It returns a result, which is either a number, meaning I summed everything properly, or it's an error, in which case something went wrong when I was trying to get my data. And so you can do this with a for loop. Just iterate over the things there. Check if it's a int 32, add it in there. But the thing you might not notice, because it's just kind of hiding there, is that we're actually handling all the errors with this one character here. So the question mark back row is very powerful, or operator, but the basic thing it expands to is doing a pattern match. And if there's an OK value and a success, it just yields that value. So in that case, it just says, okay, here's the cursor. But if there's an error, it actually returns from the current function that you're in with the error message. So it's kind of as good as being able to throw an exception, except you're still type checking it, you're documenting what error type you have here, and it just kind of works from the magic of macros and operators. And another thing you might not notice is, but you're also handling a case like, what if there is not an X field? This says if that, which is a way of doing like a single arm pattern match in Rust. So this isn't going to get an error if there's no X field. It's not going to get an error if there's an X field that isn't an integer. It will just kind of work the way you want it. And if you want to check for an int64, you can do a full pattern match and then just pass the 32 into an int64. It's actually another interesting thing about Rust, is you can't just implicitly convert integers into other types, which, again, a lot of times when you're doing that, it's not great because you have to think about, am I widening it, am I shortening it? It's nice that kind of Rust doesn't let you make those mistakes. So, did I get out of full screen here? Yes, I did, okay. So, moving on, just some projects that are made with MongoDB or using MongoDB. So someone wrote this project, Magnet, which is a schema generator, where you can give it your JSON documents and it will tell you what your schema is, and then you can enforce it in some way. There's also a thing I wrote called Monger, which is a version manager. So one thing that you want to do as a driver engineer at MongoDB is you have to test things against a bunch of different versions of MongoDB, and there's no standard way to just install all of them. So I just wrote a thing that just downloads those and lets you kind of manage them. Things that people have made with the Rust driver. Someone has started writing an ODM on top of it called Wither. There's links out there. Another thing that I just found using the reverse crate search on crates.io, the package repository. Someone wrote this app that just takes a bunch of election data from Ireland elections and just throws it into a database for you to analyze. And they wrote it using the driver, which is kind of cool because it's just like, oh, this person in another country I've never met decided to use my thing to do something useful, which I don't get all the time. So we're going to talk about futures, but not this kind of future, like, you know, robot apocalypse future and everything, right? Except for hopefully with less death. I haven't seen this week's episode, so don't give me any spoilers. So what would an official MongoDB driver look like? There are a couple unanswered questions. The two main ones, I think, are would we rewrite the driver that we have now that, again, was written by 2 interns a couple years ago? Or would we try to use the existing thing and make it better? And the other thing is there's a little bit of a quirk with the VSOC library, which I'll get into. For whether or not to rewrite it, the obvious arguments against it are people are using the old driver, they have to migrate. But again, the caveat to that is it's a 0.x version that's labeled as prototype and has a disclaimer saying not to use in production, so like, can't really blame us if we put out a new one. The other question is, do we use the same crate? Because there's already a version number history there and everything, and it's still on 0.x, so we can break API if we want. And I think honestly the cleanest thing to do is at like 0.3 now is just jump to 0.5 to say, this is a lot different than from when we did 0.2 to 0.3, which again, kind of laying out as cheating, but yeah. But the arguments in favor are just having a better architecture in general. So when Kevin and I wrote this, we had not written a MongoDB driver before. We were just learning Rust because, again, Rust wasn't even 1.0 2 weeks before we started. So there's a lot of knowledge gain that we've had since then, and we could kind of write it in a way that doesn't give 48 millisecond lags for Michael. We also can take advantage of some of the new stuff in the ecosystem. So one thing is, I think, instead of linking to OpenSSL, at the time I thought that's kind of what people would want, but I'm thinking more now that if you're using Rust, you probably want to use Rust. So there's a library Rust TLS, which gives you, TLS support in Rust, which we could use for all our SSL connections. And then there's also the elephant in the room of Tokyo and futures and like an ASIC driver. So there have been already a lot of issues on this project where people were like, hey, can you make it support Tokyo? And it would be like, do you mean you want me to rewrite the whole thing to be async? Because that's kind of hard. And they're like, yeah, that'd be great. So if we did a driver officially, we might want to consider this. The caveat is that Futures library just released 0.2 in the past month or so. So like, and that took a year after 0.1, so maybe it's not stable enough for us to release an official driver using that yet. The thing about the BSON library though is we actually didn't write it. So when Kevin and I were interns, at the time the idea for us was for us to wrap the C library with BSON, and that was just a lot of work and not super helpful. So Kevin and I were like, hey, maybe somebody already wrote a vSUN library. It turns out someone did. And we contacted them, and he was like, yeah, you could definitely use this for your thing. And then he like almost immediately granted Kevin like push access to the repo, which was kind of amazing. And so we've had a great working relationship with him. Again, he still owns the crate on crates.io. He owns the repository. He has been gracious enough to let us add features that we need. But it becomes a different story once you're a company releasing an official driver, to mostly just because like you want the fail points to be within your organization that you can manage. And so the argument against it would be, well, people would have to migrate to a new crate if we forked it or released their own. And we'd break compatibility with all the other tools using a vSUN library out there. But the upside is that we wouldn't have to rely on someone outside the company if we wanted to fix bugs, if we wanted to release a new version. Again, this is the kind of political decision that's a little bit above my head in terms of where I would be implementing things in the company, but it's a question that would have to be answered if we were going to do an official Rust driver. And the last thing I wanted to touch on is that if you really want this to happen, we need you to be enthusiastic about it. Because, again, if the company thinks that no one wants to use a Rust driver, they're not going to make one. So again, not my decision. I want it to happen, obviously, so I want you to want it to happen. So if you're a client of us and you want this to happen, talk to whoever your contact is. I don't know if it's a salesperson or something. If you're not a client, talk to our developer advocates. I mean, but be nice to Jay for me, just because he will not be happy if I send angry people at him. You can write blog posts. You can write blog posts. You can tweet at us. You can send the email, the draft they had before, and yeah. So I want to thank you for listening. Again, short presentation, and open up for questions.
Any questions for Sam? Don't be shy. Sam's a nice guy. Fair enough. There's some sodas and all the way in the back. You got to come up here.
I can speak loudly.
Speak loud.
So you said you wrote this before 1.0. And then you haven't touched it much since then. How does it?
So no, it was written. The first version. I'll go back. So the first version was written in 2013, supporting Rust 0.7. That one never really got touched again after the summer and doesn't still work. The second version is the version that Kevin and I wrote, which started 2 weeks after 1.0 came out, so it always compiles and works. Okay. But again, we have changed a number of things since then, switching from Rust serialized to survey, which did not exist at the time that we wrote it. Also adding TLS support, things like that.
Okay. Anyone
else?
What toolchain are you using now?
Toolchain as in?
The Rust.
So yeah. So the version that exists now, written in 2015, Cargo existed by then, Ruststock existed by then. So we don't mess with anything besides that. Because in general, if you're using a Rust project, you don't want to have to deal with other things than that. You want to be able to add it to your cargo.total and just have it be a dependency that compiles. You want to view the documentation on docs.rs. Well, when we released it, we actually did have to self-host the documentation on a GitHub page. But again, now docs.rs automatically is a website that automatically generates the documentation for crates that are published on the repository. So it just parses them out and puts them up there for us, so we don't have to do much for that.
The at symbol was a unowned managed pointer.
Unowned managed what?
Unowned managed pointer.
Yeah, I mean, I didn't even know what to call it when I was Googling, because you can't Google symbols, and I was like, mark, symbol, and then I was just searching for things that had the word symbol and which was lots of things that were not related at all. Oh no, you're saying what it was for Rust, I'm sorry. Okay.
Yeah, for Rust.
So unowned managed
pointer.
Well, Rust did kind of used to have garbage collection before 1.0, so yeah, I mean, like I said, totally different language then, it's not surprising it doesn't work, so yeah.
Who for sigil?
Sigil, okay, that is definitely something I did not think you were looking for, so yeah. Thank you.
Anyone else?